Okay, so the first question for 2013 FRQ number 2 is A. So S is a shaded region inside both graphs. In my very bad drawing, you can see the shaded part, and you're trying to find S's area. So some formulas to know beforehand before you get started is that the integral of a to b times half of r squared theta d theta, and then you should know obviously r equals area equals pi r squared. It's my fault. Of a circle equals pi r squared. Okay, so you know that for the curve of 4 minus 2 sine theta, it's between those 2 points that were given to as intersections, pi over 6 and 5 pi over 6. So you're going to have to take the area into two parts. You're going to have to do 2/3 times the area of the circle, r theta equals 3. So the reason you're doing 2/3 is because it does cut off at a certain point, as you can see. And because of the intersections given to you, you know that the space that you are calculating is only 2/3. So you're going to do 2/3 times the area of the circle, r theta equals 3, and then you're going to do plus this area equation that I gave before. And you're going to use the integral of pi over 6 to 5 pi over 6 times a half times 4 minus 2 sine theta squared d theta. So once you, now you can start plugging this all in, and honestly it's just calculator work at this point. So you have your 2/3, and then you're going to times it by this original area of the circle equation, pi r squared. And you're going to do 2/3 times 3 squared times pi, because if you look at this blue circle, you have a radius of 3. You can't really tell by my drawing, but and you're going to times that by pi, which gives you 6 pi, and then this whole thing you are going to put into your calculator, and using the integral sign in your calculator, and just plug this all in, and then you should get, and you add them both together, and then with your calculator you should get 24.709 as the answer, or as your area. So for part B, you're told that a particle moves along the polar curve for r equals 4 minus 2 sine theta, so that at the time t seconds, or it's given theta equals t squared. So you have to find the time in the interval 1 is less than or equal to t, and t is less than or equal to 2 for which the x-coordinate of the particle's position is x equals -1. So again, the 4 minus 2 sine theta is the black line for the circle. So something to know beforehand, before you get into it, that the conversion equation to and from the polar is x theta equals r theta cosine theta. So you're also, you know that in you're given theta equals t squared. So you're going to use that and use this conversion to basically find your final answer. So you're going to do x of t equals 4 minus 2 sine, and then you're going to plug in your t squared here. So 2 sine t squared times cosine t squared. And then you know that you're given x of t is equal to -1 for the 1 is less than or equal to t, and t is less than or equal to 2. So now you're going to go right to your calculator, and you're going to do, you're going to plug into your y1 and your y2. So in your y1, you're going to put in that 4 minus 2 sine x squared times cosine x squared. And then for your y2, you're going to do -1. You're going to set your window for between x equals 1 and x equals 2. And then you're going to hit graph, and then from there, you're going to find your intersection point between both y1 and y2. And then once you do that, you should get the answer of 1.428. So here is all the final work.